All right, hello everybody. This is Math 140, day 4. I'm going to really attack the quadratic polynomials now, which are polynomials of degree 2, and sometimes we're being inclusive and we will say quadratic polynomials include all polynomials of degree 2 or less. And what we want to do with them is factor them. So of course, you can multiply polynomials. And I should do an example for that first. 5x minus 6 times x squared minus 4 has to be, when you want to multiply this and expand it out, then you've got to use the distributive law, and that says you've got to multiply everybody in the first factor, every term, times every term in the second factor. So we have got to do 5x times x squared, which is 5x cubed. Then we got to do 5x times negative 4, which is minus 20x. We got to do the two inner terms, negative 6 times x squared, which is negative 6x squared. And finally, the two last terms, negative 6 times negative 4. And that is plus 24. This is not in standard form. You will not organize it. Bring those powers into decreasing order. But the key is that we need to multiply everything in the first factor times everything in the second factor. And the order in which I did it, the two first terms, the two outer terms, the two inner terms, and the two last terms, first, outer, inner, last, gives you the mnemotechnic FOIL. You may somehow remember this from high school. FOIL it out. When you've got two terms in every factor. If you have 3 or more terms in one factor, it's the same rule. You still need to multiply everything in the first by everything in the second factor. And it's just got to be more terms. If there are, by any chance, several terms with the same degree, so you get several multiples of x in there, you should combine them and bring them back into standard form, which I didn't have to do because I didn't encounter several terms with the same degree, but at least I shuffled them in the right order. Let's do one more example. (7x plus 1 times x plus 2. Same order. The two first terms is 7x squared. The outer terms is 14x. The inner terms is 1 times x. And then 1 times 2 is 2. And this is what I meant. Combine the like powers of x. So we have a total of 15x in the middle. So far, so good. We want to factor a given quadratic polynomial, which is the other way around. If find two factors if they exist. Sometimes it's not even possible. So looking back to my examples, maybe you noticed that the degrees of those two factors, they are 1 and 2 in the example at the top, add up to give the degree of the result, because the two highest powers multiply together and the exponents add up. And the same thing happened there. 7x times x gives 7x squared, so the degrees are 1 and 1, which adds up to give me a degree of 2. The only way that a polynomial of degree 2 can factor is into two factors of degree 1. Up to shuffling around some constant factors that do not change the degree. You can only split it into two factors of degree 1, if it's possible. So the two factors have to have degree 1. I should mention we are not counting stuff like this. 5x squared minus 20 is equal to 5 times x squared minus 4. Okay, so it is factored. There's two factors here, the 5 and the x squared minus 4. But it's just a constant. Okay, it's nice to see that. But it's still a degree 2 polynomial back there. So what really counts is if you factor it into factors and each of them is not a constant. That's really breaking it down into smaller parts. It's called a proper factorization. Both factors have to have lower degree and therefore degree 1. It's the only way to split the two into smaller integers, and therefore it's the only way to factor a quadratic polynomial into factors, apart from that one which we are not counting. So how do we do it? Here's an example: x squared plus x minus 12 and there's going to be two factors of degree 1. I might as well tell you that they both should start with an x. Of course, we want to try and find factors with integer coefficients. It starts with examples where this is actually possible. So the only way that this can happen, that the powers of x here, sorry, the leading powers, which are just x's, multiply to give x squared, is when they both have coefficient 1, okay? And then there's going to be some other numbers. Let's call them a and b. And this is the question: is that possible? So we try this out. We multiply this FOIL, okay, and we get x squared plus a plus bx plus ax plus ab. And bring it into standard form. That's x squared plus a plus b times x plus ab. And this is what we want to match x squared plus x minus 12. So what we really need is that the a plus b has to be +1, and the a times b has to be the -12. Then we would be happy. Then we'd have found a factorization of x plus x minus 12. So we go to find numbers, and let's assume we can find integers. We're just looking for integers because if you can't find those, then we'll give up. We're looking for integers, a and b, and the first condition, a plus b is 1, that doesn't limit the search very much because there's infinitely many pairs of a and b. But a times b equal to -12, there's a limited number of choices of integers that multiply to give -12. So what's the choices? It's a could be 1, 2, 3, 4, 6, or 12. And b also could be any of those numbers or the opposite. So let's just go through the choices here. If a is 1, then b should be -12. If a is 2, then b is -6, and so on. See how this works? Couple more choices. If a is -1, -2, etc., etc., then b is 12, 6, 4, 3, 2, 1. Because they have to multiply to give -12. That's a total of 6 and 6 is 12 different choices. But now we can bring in this first condition. A plus b is equal to 1. And we just go through the list here. 1 minus 12, is that equal to 1? No. Frowny face. 2 plus -6, is that equal to 1? No. 3 minus 4, no. 4 minus 3, yay. And now I can tell you a secret. As soon as you found A and B that work, you can stop. We don't need to go through all the rest of these. We find a pair of values for A and B so that it works. And this is something which it's not obvious why that's true. It's to do with a theorem that says the factorization of a polynomial into factors, like I had up there, is basically unique up to constant factors being shuffled between the two factors. You could multiply each of those factors by -1, for example, and it would still be a true equation. But if you nail down the coefficient of x to be +1, then that's not possible. You can't shuffle any factors. And then it's really only one possibility. So we find one, you can stop. All right, so x squared plus x minus 12 is equal to x plus 4 times x minus 3. And this is something you need to practice a lot. So you're looking for integers that multiply, give you the last coefficient, and they need to add up, give you the middle coefficient. and it's a fast way to factor quadratic polynomials if it works. If this doesn't work, maybe there's weird factorizations, and for that one, we'll have a different video for that case. Or maybe it's not even possible. So more episodes in this saga to come. Bye for now.